This is Josh White with JW Math Tutoring. In today's video, I'm going to go through a first look of the new Bluebook practice test number 11, the math section modules 1 and 2B. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Welcome to this video showing a first walkthrough of the new Bluebook practice test number 11, the math sections. Now, this video is basically going to be, like I said, a first walkthrough where I'm going to go through, solve this test, have not seen it, have not looked at anything, any of the problems, any part of it. So I'm going to be solving this as if this was a brand new test, say like you were taking on a Saturday for an official exam, where you have, no background knowledge of any of the questions or anything. So that means a couple things. First of all, there's going to be probably minimal or no writing on the screen. I'm going to be doing all my writing on paper here in front of me. I will try to talk as much as possible and share my thoughts out loud. As I'm working through these, but this is meant to give you the idea of the speed and timing that you need, to complete both Module 1 and Module 2 within the required time limits. Okay? So that also means these are not going to be full explanations. Okay? These are not going to be, video. This is not going to be a video where I'm going to show you maybe 3 or 4 different ways to solve a problem. I mean, I may do that on some if I have time to check them, but those videos will be later. Full solutions and explanations videos, those will be made in the upcoming days. So look out for those. This is just a first walkthrough video of the new Bluebook practice test number 11 math sections, and basically to see can I get an 800 on this test. So see how it shows up now. Practice test 11. All right, now I'm not going to bother doing any of the reading and writing sections. Those, if you just want to skip them, you just click go to review page and then move on to the next one. Same thing for Module 2. All right, so now we're ready to go ahead and start the math section. Okay, so now I'm ready to go ahead and start the math section. Now, on my paper, am just going to write out the numbers for each problem because I'm going to record the answers as I go through and hopefully have enough time just to check them at the end. Okay, so let's see here. Which equation has the same solution as the given equation? All right, so we just subtract 1 from both sides. It's just going to be 4x equals 32. That's going to be letter A. Next, we have a function. What is the value when it's equal to 2? So when x is equal to 2, we're plugging in 2 for x. 2 cubed plus 110. 8 plus 110 should be 118. A. Double check this in Desmos. K of 2. Yep, 118. Also, let's expand this out. All right. Make sure I select that. Okay. Next, we've got tasks. We've got time for the task. What was the mean time? Okay, so this is just asking for the mean of all those values. The task number is irrelevant. We're just asking for the mean of 5, 2, 15, 9, 9. Looks like it is 8. Nine. All right. Okay, here we have, let's see here, an interpretation of linear functions questions. Number of 2009. Okay, 2009 is X, 1996 is Y. 6, 1996 pennies. Okay, so again, 6 corresponds to Y. So this is basically 8x plus 11y equals 170. How many 2009? Okay, the number of that is X. So basically what all this is saying is, okay, when we plug in 6 for Y, what do we get for X? So that's just 8x plus 11 times 6 equals 170. Looks like it's 13. Just confirm this. Okay. 13, 170 minus 77. Yes, that would be 91. 8x equals 91. 13. Okay, what should I describe this? Okay, this is obviously an exponential function, not a linear function. It's increasing because it goes up from left to right. So the answer to this is obviously B. What's equivalent here? Okay, 6x plus 5x is 11x. The 4y doesn't combine. This is just 11x plus 4y. So that's C. Okay, congruent triangles, A to D, B and E are right angles. A is 27. What's the measure of F? All right, sketch out my picture. Let's see. B is a right angle, E is a right angle. A is up here, A corresponds to D. Okay, F is down here, C is down here. Okay, so A is 27. That means D is 27. That means F is going to be 90 minus 27, 63, or 180 minus 90 minus 27, if we want to think about it that way. All right, next. 240 players matches. Each player will play match against another player in round 1. At the end of each round, the player who loses... Number of players eliminated at the end of round R. Okay. So, first of all, we're starting with 240 players, so it's going to be either C or D. It's going to be 240 out front. And it should be... It should be C because basically half the players are going to be eliminated, like after each, after each round essentially. So, at the end of round R. Okay, so let's say round 1, R equals 1. Okay. After round 1, we should have 120 players left. We start with 240. Everyone gets paired up, so there are 120 matches. Therefore, there's going to be 120 winners and 120 losers. So if I look at these answer choices, this, say R is 1. Okay. 7.5? No, that doesn't make any sense. So I'll get rid of this. Okay, so that's wrong. Yeah, this one's going to be wrong. 240, this is answer choice D. No, there can't be 480 players eliminated because there aren't even 480 to begin with. After round 1, it's going to be 120, and then there's 120 left, and they all pair up, which means after round 2, it should be 60, which is correct, which matches here. And then after round 3, it should be half of that, which is 30. So yeah, this one's just letter C. All right, here we have a formula question. Which expresses R in terms of, okay, all we have to do is just multiply both sides by 38. 38 times S plus T. We don't need to use Desmos for this one, so it's letter C. Next, okay, this line is parallel to what defines line J. Okay, so the slope of line K is 6. That means the slope of line J is also 6. So it's y equals 6x. Oh, it's got to be A by process elimination. We don't need to check the rest of it. I mean, they give us the y-intercept point, which is 5, so it's 6x plus 5 because B is 5, but it doesn't even matter because the others all have the wrong slope. Okay, next. Okay, length of one side is 6 times the length. The area is of n is 49. What's the area of m? Okay, so scale factor. M is 6 times that. Okay, so the scale factor is 6. That means the area factor is the square of that, which is 36. N is the smaller one, so 49 times 36, whatever number that is going to be the area of square M. 1764. And we could also just double check this real quick. Okay, if n is a square and its area is 49, that means it is 7 by 7. Okay, the sides are each 6 times larger. That would mean it's 42 by 42, 1764. Okay, good. Letter A. Which quadratic has exactly one distinct real solution? This one's obviously going to be A. We can just confirm this by graphing it. If we just graph that, we can see it's right there. All the others you're going to move over. Yeah, we're going to move over a number, and therefore the vertex is not going to be on the x-axis. It's going to be above it or below it, which means, or no, I guess it would be, yeah, above it or below it, which means either two distinct real solutions or no real distinct solutions. In any case, yes, this one's going to be A. $9.50 for the first 3 hours, an additional $50 for each hour. After that, the total cost. Answer 3 is one. Which equation represents this situation? Okay, this is like that word problem they always give at the end of Module 2, except they'd ask for the final equation, and this one is not the final. Alright, so the way we actually set this up is basically it's, right, $9.50 for the first 3. Okay, so it's $9.50 times t minus 3 plus 50t, and then that's equal to the total. We obviously need a 50t because each additional hour is t. And then t is greater than 3. That many. Oh, wait, no. 50 times t minus 3. No, not A. It's not A, it's C. It's the 950. That's the initial like flat amount, and then the slope, the 50, the additional incremental hour. That's what's multiplied by the say t minus 3. Because basically, if it's like 4 hours, you want 950 for the first hour plus, and then 4 minus 3 is 1. 1 times 50 is 50. So you'd add on one $50 charge. So this one's going to be letter C. All right, linear function. What's the value of b? Let's just do linear regression. 1, 2, whoops, 3, 4. It's going to be 36, I believe, because it's going down by 4 as you increase the x. So if you do the opposite of that, yep, 36, it's D. All right, the population of this town doubled over 75 years. It was 240,000. What was it back in then? Okay, so the question is, how many times did it double between 1659 and 1959? In other words, how many 75-year periods are there? That's basically what it's asking. 1959 minus 1659, so that should be, what, 300 years? Divide by 75. Okay, so there's basically 4 doublings. So essentially, we're going to divide this in half 4 times. Or in other words, 240 divided by 2, 1, 2, 3, 4. Should be 15,000. Let's just double check it to confirm. Okay. 75 years. Whatever that is. 1730 something. Then another 75 years. Now we're like just past 1800 something. Another 75 years. Now we're at like 1870 whatever. Something in that ballpark. Now another 75 years. We're at 1959. It's doubled 4 times. Yes, it checks. Should be 15,000. All right, next. Which one is the slope of this line? All right, so it looks like it's on 3.5. Where else is it pretty close to? 8.8. 8 minus 5, 8 minus 3, 8 minus 5 is 3, 8 minus 3 is 5, 3 over 5.6, A. That's what it looks like. What did I say the 2 points I got were? 8.8 and 3.5. Yeah, 0.6, A. Okay, we have a quadratic function that shows 3 values and their corresponding things. Okay, so the vertex is at 27 something. I know that. All right. Easiest way. 8, 30, what's going on here? Negative 8, 32, 8. C is 7, 12. Okay. All right. Let's just see which of these overlap completely. All right. Do they overlap completely? No. What about this one? Yes. Yes, it does. So yes, it looks like it's going to be letter B. I don't think we need to check the next two. I mean, they both have like, yeah, this is nowhere close. I don't need to bother checking C and D, but it's going to be B. All right, circle. So it's going to be x minus 19 squared plus y minus 18 squared. Okay, great. They all have that. That doesn't help us. Radius of 9k. So 9k squared is 81k squared. We need the one that has 81k squared on the right, and that's it. Yeah, the h and k values are the same, so it's really just looking at the radius. All right. $127,000. Okay, whatever. Which of the following is closest to the estimated mass of each M-type star? Okay, they tell us the total mass is 127,882. They also tell us the maximum number of M-type stars. Looking at the graph here at the intercept value, it's like, I don't know, 158, something like that. In other words, if you had only M-type stars and we didn't have any K-type stars, there would be 158 of them. So the total mass divided by the total number of stars will give the estimated mass for one individual star. So one of these is going to be close to the number. Okay, yeah, it's going to be A. It's 811. Also, what did I put? Yeah, I put B for the last one. I just didn't write my answer down. Okay, next, QR is less than RS. Which expression represents the length of QS? Okay. So it's sine, okay, it's all basically sine Q or cosine Q. So sine Q is opposite, which is RS, i.e. 18, over hypotenuse, QS. Cosine Q equals adjacent, QR, over hypotenuse, QS. So now if we rearrange that, I get QS equals 18 over sine Q, or QS equals QR over cosine Q. So which of these two do I see here? I see 18. The only thing I see 18 divided by sine Q. That's what I got down here. Again, we're solving for QS, which is the hypotenuse. Sine Q equals opposite 18 over hypotenuse. So the hypotenuse is going to equal 18 divided by sine Q. Yes, letter D. All right, let's look at 1,000 revolutions per minute, 6,000. Okay, this question has a ton of words, but this is just a linear function we can just plug in using regression. Okay, let's just do it. F is the power and x is the engine speed. So the first thing, engine speed 3331, power 433. Engine speed 4500, power 600. Okay, my 1 tilde 1/7, x1 minus a plus 433. What is the value of a? Looks like it's 3331. Okay, does that make sense? Your equation is basically power is 433. Yes, that does make sense. Okay, because if you think about the equation, you got 1/7, and then if you plug in 3331 for x minus a, and then at the end we've got plus 433. And on the right side, that has to, like when x is 3331, the output, the power is 433. So on one side you have 433, the other side you have a plus 433. For those two to be equal, that means the whole 1/7 like expression thing has to go to 0, and the only way that happens is if a is equal to 3331, because then it'd be 0 times 1/7, which is 0. So okay, yes, that's correct. Oh goodness, how many distinct real solutions does this have? The first let's just graph this. The first one is going to be, first of all, the 52 doesn't matter, but yeah, this one's just going to be 1. It's -4. The other two are complex. I think it's going to be 3. So the first one, you can technically factor it using the sum of cubes formula. It's going to be x plus 4, and then x squared minus 2x plus, no, x squared minus 4x plus 16, if I remember correctly. But the other thing is going to have 2 complex, so we can ignore that. So you're going to get a -4 from that. And then the x fourth minus 81 is x squared minus 9, x squared plus 9. Okay, x squared plus 9 gives you complex solutions. Ignore that. X squared minus 9 gives you x plus 3, x minus 3, x equals 3, x equals -3, +3, -3, -4. So I get exactly 3 distinct real solutions for this, letter B. All right, so I have some time left. Let me just check. Oh, that's not what I want. Let me just run through these real quick, make sure my answers match. Okay, number 1, A. Number 2, A. Number 3, 8. Number 4, 13. 5, I have B. 6 should be C. 7 should be 63. 8 should be C. 9 should be C. 10 should be A. 11 should be A. 12 should be A. 13 I have C. 14 I have D. 15 I have 15,000. 16 I have A. 17 I have B. 18 I have B. 19 I have A. 20 I have D. 21 I have 3, 3, 3, 1. 22 I have B. Okay. Now I'm just going to use this time just to do the labeling for the second module, since they don't take your scratch paper away, after you finish one module. All right, let's now take a look at Module 2. Okay. This pass cost $19.50. She purchased 10 identical stickers. The stickers in the pass cost 62. What's okay? 1950 plus 10x equals 62. What is it? 425. Looks like it's letter B. 1950 plus 10x. Yes. All right, next one. Solution again. What's the value of? All right. Okay, what's the value of y? It looks like they intersect here at 95.30, so I'm going to say the solution is 30. Okay, goes to packing store, blah, blah, he has $15. Each container costs $187. Each roll of tape costs $240. Which inequality represents the number of containers? Okay. All right, so 187 has to be multiplied by C. 240 has to be multiplied by T. 187 plus, okay, so it's either A or B. And $15 is the most he can spend, so that's the upper limit, so it's A. It's not the minimum he could spend. That's what it would be if it were B. But, okay, so it's A. Alright, it's obviously a positive number. It's pretty flat. It's probably 0.22. But let's just look here. We've got a 0.23. We've got another point here, 7.4. 4 minus 3 over 7 minus 2. 4 minus 3 is 1. 7 minus 2 is 5. Just using the slope formula, that's 0.2. So it's going to be letter C. Alright, the boiling point of something with molecular weight and blah, blah, blah. Best interpretation of this single point. Okay, so X is the weight, Y is the boiling point. So 149.02 is a weight. Molecular weight. Okay, so A is out. Okay, boiling point. The minimum estimated, maximum? No, these aren't mins or max. This is just the regular. If this is the weight, then this is the boiling point. So, okay, this one's just going to be B. Let's just go to Desmos. I didn't type it right. 7, f of 2 minus g of 2. 44, D. Let's just see here. F of 2 is 8. 7 times 8 is 56. 56 minus 12, yeah, 44. It's D. The radius of B is 2 times the radius of A. Okay, radius of A is square root 25, which is 5. That means the radius of B is 2 times that. 5 times 2, which is 10. That means the radius of B squared is 10 squared, which is 100. Therefore, K should be 100. 63 equals 9 times 2x plus 3. Divide both sides by 9. 7 equals 2x plus 3. X equals 2. Should be. Yep. Okay, next. Alright, we're going to go straight to Desmos to do this. K is 29. Excuse me. And just double check it. It's B squared, which is 49, minus 4 times 1, which is 4, times 5, which is 20. Yeah, 49 minus 20, 29. Okay. What's the x squared term? Alright, it's minus 5x squared minus 3x squared, negative 8x squared, I believe. This one should be A. It's y less than 60 over r. But this thing is technically equal to, y greater than negative 4. So how do you turn 60 over r into negative 4? You divide it by negative 15, and that flips the sign. But let's just double check it in Desmos. ry less than 60. R equals negative 15. Do we have the same, get rid of this, do we have the same graph here? Yes, it's at -4 and it's above it. So yes, it's negative 15. Letter D. Set K is all equal to 160. Okay, positive integers less than or equal to 160. So total outcomes is 160. That's our denominator. That is even and less than or equal to 50. Okay, so 1 to 50, we have 50 numbers. Half of those are even. That means there's 25 of them. So it's 25 out of 160, whatever that reduces to. 5 over 32. Again, even and less than or equal to 50. So there's 50 total numbers, 1 to 50. Half are even, therefore there's 25. So 25, yeah, 160, which is just equal to, what do you say, 5 over 32. A. 18 points. Okay, so there's 50 players. That means originally the median is the average of the 25th and 26th values. Now with the 51st player, the median is the 26th value. Okay, so originally, it's like 4 plus 7 is 11. 11 plus 26. Or coming this way. Okay, so the median originally is between 50 and 60. Like, the two numbers have to be in there. The median of the new is still going to be in there. You're just going to add one value, so it's like 1 plus 4 is 5. 5 plus 7 is 12. And then you cross the 26th value and you add 26 up here. More than 25, whatever it is. Okay, so which one? The median for B is less than the median for A. I think no, that is not true. The mean for B is less than the mean for A. Yes, the mean will absolutely drop because you're adding a number, which is a value, which is 18, which is smaller than all the existing values. So 2, yes. This one should be B, 2 only. All right, 1 inch is equivalent to a length of 17/3 feet. If the length in the actual office building, x feet, which of the following represents, okay. 1 inch, 17/3 feet. That's equal to x feet. Yeah, so we want to know whatever the thing is here on the model. We'll call it y. Okay, so we just multiply by x, cross multiply. Or no, just multiply by x. We don't need to cross multiply. We get x over 17/3, that's equal to y, and then technically we could bring the 3 up top, 3x over 17. We don't need a 12. Yeah, I don't know why. Inches, feet, feet. So the corresponding things they can have different units, but the corresponding parts have to match up with the same unit. So feet, x feet, 1 inch, how many inches? 3x over 17. This one should be letter C, but maybe come back to that one if we have time. What's the value of n? All right, let's go to Desmos. And just knock this one out here. Cube root p squared, no, comma, t tilde p to the 9/7, comma, p to the 3n minus, oh, goodness, minus 1. Get rid of this. Nope. Yep, okay. Alright, how do I zoom in here again just to make sure? Yeah, it's 9/7. Yeah, notice the value end's not changing. Alright, so is this a fraction of some sort? Yep, 41/81. Again, that one I could come back to and double check by hand, but I don't think I need to do that for right now. Okay, okay. We know that. Yeah, let's just go to Desmos and do this. -22, 0, y1 tilde, x1 squared minus x1 minus a, x1 cubed minus x1 minus b. Okay, what is the value of b? I show 23. Let's see, if g of -22 is equal to 0, well, that's how you get a. And then you plug the 0 in, but okay, whatever. We don't need to double check. I mean, whatever. You come back and double check this one, but yeah, answer's right there. It's b is 23. Next. I've seen this one. Okay, this one I have seen multiple times before. Let me just pick my answer. Let me see. Let's say I let x equal 70. Is that? No, 9 times 9 times 70 minus 140. No, way too big. 10? No, what did I pick before? 20? Yeah. Okay, so rather than doing this whole thing out, one angle is 40. I'm letting x, okay, let's let x equal 20. One angle will be 40. One angle will be 140. So let's do this actually. Let's do it this way. x1 equals 20. Now I can just type it like this. I think that's my answer right there. x1 minus 280, 180. Okay, so basically there's like multiple different combinations we can have here. We can do 140 and 40 adds up to 180. Okay, so it's obviously not that because we're looking for the one that doesn't exist. We can do 40 and 40. That adds up to 80. Okay, that's this one. All right, that's not the answer. We can do 140 and 140. That's 280. That's this one. Okay, so by process of elimination, it's A. Okay. This is just a straight repeat from practice test 5, I want to say. All right. Maybe not. Maybe they changed the numbers because the correct answer, I think, on that one, it's actually 54. So, okay, whatever. Maybe the numbers are changed, but let me just quickly sketch this one. Y, Z, Q, X, W, A, A. Okay, they're similar because of the vertical angles. YQ is 21. WQ is 70. So, okay, the ratio is going to be 21 to 70. WX is 60. XQ is 120. What's the length of YZ? 21 over 70 equals x over 60. Basically, it's 21 times 60 divided by 70. Yeah, 18. Looks like it's letter A. Equals 7. Here is 3x plus 13.5, y equals 10.5. Okay, if it has at least one solution, which could be the other? Okay, so do we have at least one solution here? Yes, we have an infinite number of solutions. So technically, 1 is good. What about if I do this? Yes, I have exactly 1, which meets the criteria of at least 1. So, yes, it looks like 2 is good as well. So this should be letter C, 1 and 2. All right. Let's see here. Okay, base area. Draw my prism. Okay, 8/3 x. So 8/3 times x or whatever equals 24t. Sorry, 8/3 times, we'll call it 24t. The height is 15. Okay, what's the total surface area? So the area of the base is 24t. There's 2 of those. So that's 48t, okay, from 2 bases. Then we find the other unknown side by doing 24t divided by 8/3. I think that's going to be 9t. It's technically 24, yeah, 24t divided by 8/3. Yeah, it's 9. Okay. 9 times 8, 72 divided by 3, 24t. Yeah, okay. So now we've got 48t for the 2 base areas plus 2 times, the left and right are going to be 15 times 9t. And then the front and back, there's 2 of them, and their things are 8/3 times 15. Goodness, all right. 2 times 15 times 9. Okay, that's how many t's there are. That's 270t plus the 48t. And then 2 times 8/3 times 15, that's 80. 48 plus 270, 318. 318t plus 80. Is that an answer? Yes, letter B, right here. Okay, let's see what we have here. So we have g of x. Then they're asking us about g of x plus 28. What could be the value of b? Alright, so we can, let's see, we can do this one in Desmos, or actually should be able to reason our way through it. Okay, so originally here, the original g of x, you've got x plus 2, it's technically x minus negative 2, x minus 1, x minus 3. Then you do plus 1/28, or plus 28. That shifts it to the left by 28 units. So basically you're just adding 28 to all these parentheses. So it's now like x plus 30, because the negative 2 moves over to negative 30. The 1 moves over to negative 27, and that's the same, x minus 1 plus 28, x plus 27. X minus 3 plus 28 is x plus 25, and if you take 3 and you move it to the left 28 units, you get negative 25. Okay, so this is the result. Okay, so I've got the new function after the shift. Which of the following could be the value of b? So b is either, since it's of the form x minus, it's either negative 27 or negative 25. Do I see either of those answers? I do. Alright, so this one should be D. Let me just go to Desmos and just fool around with this one and confirm it. Oh, I wonder if I could get the graph by doing this. Let's see if I can do it this way. Okay, we have this. 1, 0, 3, 0. Looks like it goes through 4, 6. Wait, I don't even need to do this. I already know. Wait, yeah, I don't even need to do this because they give me the 1/10. Maybe it's not 4, 6 because I mean, if I just get rid of this, yeah, I don't even need to do. I don't need to do that. What am I wasting time on that for? Just here's this. Here's this. Yeah, this one's going to be plus 2. This one's going to be minus 3, let's say, and minus 1. Okay, and that looks like, this looks pretty close to our graph here. Same general shape. Okay, now I'm going to do a new function. Alright, get rid of the original, zoom out. Okay. So here's my new function. So my b, which are the zeros where it bounces, i.e. has a multiplicity of 2 where it touches, it could be negative 25 or it could be negative 27. So yeah, okay. That one's just letter D. Okay, we have an advanced percentage question. All right. A is 468% weight of B. Okay. A is 0.780% of C. And then C is P% of B. What's the value of P? Okay, I get, is it 60,000? Looks like 60,000, but let's just double check here. Like they're saying B equals 1. Let me just set B equal 2. And just like move the slider. Yep. A is 468% of B. A is 0.780. Just make sure, yeah, I typed the decimal point there. And C is P% of B. Yeah, that should be, I mean, it's really just 4.68 B equals 0.0078 C. So it's just whatever 4.68 divided by 0.0078, 600. That's the decimal form, but if they want the percentage form, of course, we have to multiply that by 100. Okay, so let me type that in. All right, looks like everything's been answered. Let me just jump back real quick here to 14 and 15, since I do have some time. All right, so let's just do a picking numbers thing for this one real quick. 1 inch, 17/3 feet. Okay, now let's say the length in the building is 17 feet, meaning we're going to multiply by 3, okay? So now if you go ahead and like whatever, work this out, solve this out, I get 17 over 17/3, which is just 3. So, in other words, if I let x equal 17, the answer I'm looking for should be 3. I'm just going to use x1. x1 equals 3. Okay, that's okay, clearly wrong. Let's put this up here. 12, 3. Okay, that's clearly wrong. 3, 17 inches. Y. Wait, no, no, no. No, no. X is 17, x is not 3. What am I doing? I'm doing this all wrong. Okay. X is 7, x1 is 17, and I'm looking for 3 as the output. Okay, so this is C, and that's correct. But just to double check, so obviously A, if you add this down here, okay, that's clearly going to be wrong. And then if you, for B, move this up here, and then 12 times 3, okay, that's clearly wrong. And then if you just put this here, yeah, okay, so it's C, that just, picking numbers, that just confirms it. Let's look at this one. Let's like just do the workout for this one. P to the 2/3 equals T to the 9/7, and we know that T is equal to P to the 3n minus 1. P to the 2/3 equals P to the 3n minus 1 raised to the 9/7 power. Goodness. Okay, so it's now they're both in terms of P, so now I can just set them equal. 2/3 is going to be equal to 9/7 times 3n minus 1. What do I get? Yep, 41 over 81. Also 0.05 or 0.5061 or 0.506. Those are also acceptable. Okay. Just see if there's any to double check. I mean, this one we did in Desmos. This one I've seen before. This one, know how to do. This one we don't need to double check. This one I'm pretty sure of. What the heck? Let's do this. Let me just like run through this one real quick. Okay, so if you plug in 0, or no, you plug in negative 22, and you get 0 as your output. You got 0 over a bunch of stuff on the bottom that doesn't matter. Negative 22 squared minus negative 22 minus A. 0 tilde negative 22 squared minus negative 22 minus A. Okay, so I get A is equal to 506. Okay, now on the top, now we're going to plug in the 0, 22 point. 0 minus 0 minus 506 equals 0, 0, negative B equals 22. So the two negatives cancel. I get 506 over B equals 22. 506 divided by B is 22. B is 23. Same answer, letter A. All right, let's just run through these real quick, just make sure I have the same answers here. Okay, B, 30, A, C, B, D, 100, A, 29, 10A, 11D, 12A, 13B, 14C, 15, 81, 16A, 17A, 18A, WX, 60. Yeah, it's got to be smaller than it. It's got to be smaller than it. Sorry, 19C, 20B, 21D, and this one's 60,000. Alright, so let's check out my score on this. Alright, so just give me a second to sign in on the other screen. Okay, here it is, right here, and we can see got a perfect score of 800, practice test 11, score details, 44 correct answers. Okay, obviously I've skipped all of the reading questions, but if we scroll down here, you can see with the math, everything was correct. Okay, so just going to add some final thoughts about this test and this video coming up now. All right, so I just want to mention a couple things about this test after having gone through it the first time. First of all, I was disappointed overall with the difficulty level of it. I did not find it to be that difficult. I think the real official exams are a bit more difficult than some of these, and even when you look at this test compared to some of the existing practice tests that are out there, I think there are significantly harder problems on some of them, especially 7 through 10. And there's also did not appear to be a lot of trigonometry on this. Just I believe one question with the cosine or sine q thing for RS. So that I would say was a little disappointing. Another thing I do want to mention is though, I went through in Module 2, I counted up, I believe, 5 or 6 problems, especially in the latter half of it, that I had already seen before or knew exactly how to solve. And the reason is because those problems were part of my official problem test worksheets, that I make the worksheets for and do the videos on every month when there's an official exam. So if you're not doing so already, you definitely need to go and check out my playlist. I'll put a thumbnail up on the screen here for the official test problem set videos. There was the one with like the p to the power and t to the power, the one with like the a and b where they give you 2 points for the rational function. I'm trying to remember all of them. Looking at my notes here. What were the other ones? Oh, the one with the surface area of the rectangular prism, where it's like the base area is 24t and one side is 8/3. Like that's a problem we've already seen before. Basically directly seen before. So some of those problems I worked through them very quickly because I had seen that exact type of problem before. I did not know that what the problem would be, until it showed up on the screen while I was taking this test, obviously. But I've seen those problems before. I've done those problems before. I know exactly how to solve them, and when you can use Desmos or when to solve it by hand, and so on and so forth. So this might not exactly be an accurate representation of, how quickly uh, to move through, Module 2 when you're facing a brand new test that you've never seen before. However, that being said, if you check out the official test, problem sets and work through those and practice with those and complete the worksheets and watch the solutions and everything, then you should be prepared. Then you would be prepared. If you went to take this practice test, you would have recognized multiple problems on it that you are familiar with and aware of. All right, so with all that being said, again, this was just a first walkthrough. I will have full solutions and explanations to all 3 modules of this test coming up soon, so be on the lookout for that. And of course, also check out my Ultimate Desmos Guide to Digital SAT Math. It's now up to over 7 hours, 73 total problems, multiple tips and tricks, and covers a wide range of topics to help you ace the digital SAT math section.